excited. And then when we first make these genetically modified cells, and we grow them in the conventional two-dimensional cell culture system. So as you well know, in cell culture dishes, the neurons are differentiating in the bottom of the plate. And then these are cell culture media, and then they start differentiating for 6 to 8 weeks and more than that. And what we found is after 42 days or even 6 months, we do not see any clouds, any tangles, nothing. It is interesting though, we see huge amount of soluble A-beta species in the media, but we cannot detect any clouds or tangles. So initial failure was very, very hurting to us. And our postdoc who work on this project is almost like in the depression mode because huge amount of work, high amount of A-beta, why they are not making technological change. And one thing we realized is that what we've been doing is that in this culture, we are changing these media every 2 to 3 days. So what is actually happening was that we have a pathogenic A-beta secreted out the media. And then, unlike brains, we are washing it out every 2 to 3 days. So we are actually clean up A-beta by changing media. So that was actually very we always do. So what if we are making them in the 3D culture condition? So these are the native cell. In these culture conditions, cells are differentiated in the shell. And then most importantly, those secret A-beta is accumulated inside the gel and make a high concentration to make an aggregation of pathogen cascade. So that was the whole concept of 3D culture. And these 3D culture would accelerate A-beta accumulation and then would lead to the more robust pathogen changes. And I think this is probably helpful for some of the researchers. So what we designed is 2 different types of 3D cultures, which is so-called 3D thin layer culture and thick layer. Especially thin layer culture, this is just 200 to 300 micrometers, and you can make it in every single route. And this is extremely easy. And then makes about 2 to 3 cell layers, and then you can do a lot of applications. And recently, it's not published at that time, but we are even extending this scale into the 6 cell plates. As you can see, there are no secret ingredients here, just the plain culture dishes. And then this gives you enough amount for the biochemical studies. And if you need a huge amount, in the end, you can even make this thick layer culture. This is about 4 millimeter thickness, size of mouse brains. And then you can grow them, and you can do the biochemical analysis, but also you can do parting sections to see what's going on. It's almost like small mini mouse brains. And this is one of the first data, and this you can appreciate here that this is 3D reconstituted human neural cells, and this one is differentiated for about, I think it's a 6 months old. So one of the advantages of 3D culture, unlike 2D culture, you can stay very longer. In 2D culture, IPS will well know that after 7 to 9 weeks, cells start detaching from the bottom and they wash them away. But in the 3D culture, they are really tightly making connections together and we can grow very old. And then this is first data we are very excited about. So now you can appreciate these A-beta ligands, like things in the middle of these networks. This is these sections. It's quite exciting for us because we never see this with the 2D culture model. And 3D really makes them this condition. And this is another, the A-beta flat staining, but this is from the thick layer culture, you see. And then you cannot see through it because it's very thick. So we need to do parting section to cut it out. And then you can also appreciate this is the A-beta relates. And if you're looking at here, this is neurites network. And when there's A-beta accumulates there, you can see flags. So it's physically make it push out those neurites out of space. And so this is a very tight evidence. And so another interesting thing is that this methodology is applicable to not only red cells we have, those stem cells we use at the beginning, but it's applicable to all the iPS-derived cells. And this is one of the examples. This is ILTNES, the iPS-derived human neural stem cells. And this is I think this is 4 months old, 4 months old differentiated 3D. And you can see these human iPSC in the 3D is robust connections inside without any problem. So this 3D culture methodology can be also applicable in diagnostic